Hi, my name is Chance McCall, and I'm here to talk about Fleet Metrics, an individual aircraft tracking tool. And I'm with TDA out of Falls Church in Marietta, Georgia. Let me start with a little bit of background on TDA. We've been around since 1997, headquartered in Falls Church. I work out of the Atlanta area in Marietta, and then we have a satellite office as well in Lexington Park down by the Naval Air Station. Primarily work for structures division of the Navy, and the objective is we're really in the world of structures in terms of useful life extension, as well as software development. And a good starting point for this SBIR is a Phase 3 success story, an application called the Aircraft Component Tracking System. This is a software tool for tracking life-limited aircraft components, say dynamic components that can be swapped, refurbished, replaced. It's been within the H-60, as of 2018, has saved over $120 million. And some quotes from the fleet are that it's a user-friendly system, greatly improved accountability, and what it really did is replace paper-based component tracking with a web-based system. And what stemmed off of this was, in addition to looking at individual components for life-limited parts for tracking them, also extending that to the full airframe. How can we optimize the fatigue life of each aircraft? And what that really boils down to is accurate data capture and accurate tracking. A couple of immediate applications would be the individual aircraft tracking within the context of the P8 and a similar system with, in this case, named the structural fatigue life tracking application for the MQ-4C Triton. Now, legacy approaches from a number of years ago have been that aircraft will be tracked based on flight hours and landings, for example. However, what that doesn't take into account is the uniqueness of how each aircraft is operated. Things such as weight, the type of mission flown, the environment, whether it's clear air, whether it's turbulence, whether it's over land, whether it's over sea, and even tendencies of pilots. Two pilots flying the same maneuver can have variations in terms of the severity from a structural standpoint. And because of this, because of a legacy tracking based on hours and landings, it was typically with a fairly early retirement date, likely earlier than needed. So with individual aircraft tracking programs and with enhanced data capture, data management, these formerly conservative fatigue retirement times can be accurately determined based on actual usage of each aircraft. That could also be used on, say, a flight-by-flight basis to flag safety issues, tailor maintenance to specific aircraft usage. For example, maintenance may differ based on hard landings as opposed to more benign landings. So things like that can be taken into account on an aircraft by aircraft basis. So we have a technology called Fleet Metrics, and Fleet Metrics, which originally was the concept was related to flight data capture, just the actual recorded data, is a product that can be embedded within IAT, let's say in direct support for PMA 290 at the Navy, and extension beyond that for a range of naval aviation assets. And it includes what we've broken into 4 features. Flight visualization. This came under the term of MFOQA a number of years ago in terms of trying to close the loop with pilots and give them insight into regimes that are flown and how that relates to safety and fatigue life assessment. And then the next feature is mission planning and prognostics. And what this is it's one thing to kind of put together the legacy usage of an aircraft to make assessments about the structural fatigue life of the aircraft to date. But what about forward looking? How can we examine what if scenarios? What if we chose to fly these types of missions? What if we mixed up the percent of aircraft that we're using for training? How do these training missions affect fatigue life estimation? The next one is gross weight CG estimation. We'll talk about this in the next chart or so, but a key ingredient for life assessment is understanding the weight of the aircraft, and that's not always something immediately or accurately known. And then the last one would be in post-flight. How can the fleet user view and validate exceedances during a flight. Maybe it was a hard landing, maybe it was an overweight landing, maybe it was an overspeed. To go in and make assessments about what was done, how can this lead to changes in how I fly tomorrow, and importantly, does today's flight have any immediate impact in terms of, say, inspections? So this fleet metrics technology is currently at a TRL of 6. Last August, we completed a phase 2.5 enhanced for this effort. It was a 2-year effort, tackling the 4 points somewhat in series because some technology feeds into the other, arrived at a TRL of 6. So now I can drill down a bit into these features, highlighting advantages and benefits. So for flight visualization, the real key here, so we have a flight replay on Google Earth, so you can see the kinematics of the aircraft in terms of the motion of the aircraft, what event, what flight regime you're in, maybe when high Gs were pulled, things like that. By visualizing the flight, you can understand the correlation, the relationship between usage and damage leading to structural fatigue life assessments. Mission planning and prognostics, the taking past usage, predicting when maintenance will be needed. So you could look at, as I make choices about how to fly certain missions or which aircraft fly certain missions, I can look forward to make estimates in terms of when maintenance will be required and ultimately when components will need to be replaced. Gross weight CG estimation, again, the key here is understanding the weight distribution on the aircraft in terms of total weight, in terms of how it's spread across the aircraft. It's really a fundamental element of loads development, which leads to structural fatigue life assessment. And it's not always available. Sometimes it's paper-based, sometimes it's not accurate in flight in terms of fuel usage or store drops, things like that. As we can capture it, analytical representations of it, it just gives more confidence in the fatigue life assessment. And then lastly, the post-flight analysis tools, as the fleet user can view operational exceedances that occurred, it quickly gives the ability to either provide educational opportunities to how to do things differently next time, or notification of, okay, based on certain events that happen in flight, perhaps inspections are required. In terms of application, transition to the fleet, the primary advocate is PMA 290 in the context of existing and future individual aircraft tracking programs. Transition beyond phase 2 can be via integration in the individual aircraft tracking used for the Navy for P8. Next steps would be application to their full legacy data set and then extension to other platforms within the PMA 290 family, for example, starting with the MQ-4C Triton. There's a very large market for this technology, even within the P8. There are commitments from a range of countries. There are existing partners such as the UK, Australia, New Zealand, and Norway, and as others come online, India, South Korea, et cetera, that could be $10 billion worth of aircraft. MQ-4C should also be considered smaller fleet, but a cooperative mission with P8, so it makes sense to use common technologies. And then this type of technology in terms of aircraft fatigue life estimation based on accurate metrics of usage extends to all other DoD aircraft operators, Air Force, Army, and even potentially back at the aircraft manufacturer. So partnership, as part of the transition, there's benefits for any new aircraft under consideration, especially those with common threads in terms of, say, how P8 for the PMA 290 is tracked and how usage leads to more accurate capture of usage, and assessment of usage leads to more accurate life assessment. So the benefits are decreased cost and schedule during the source selection phase as well as in the design phase, because there's less uncertainty in the forthcoming usage capture and usage assessment and how it impacts fatigue life. So sources beyond the U.S. Navy could be at the OEM level. There's benefits for them in terms of as they put together a strategy for fleet support, and also the operators themselves, Navy, Army, Air Force. So if this is interesting to you and of interest to discuss further, I encourage you to please contact me. Again, Chance McCall. I can be reached at the phone number and email listed below. Our corporate address, our Falls Church headquarters, are listed, as well as my office in Marietta outside of Atlanta. Thank you for your time and look forward to talking to you.